Today I have a very short video on resolution. This video assumes that you're already familiar with propositional resolution, but here's just a quick introduction. So assume we have two clauses and we're trying to resolve them, and we're able to resolve them because in one case we have a positive atom, and in one of the clauses, in the other clause we have the identical but negated atom, right? So we have a positive case in one clause and a negative case in the other, and we're resolving those away, and we're left with everything else that was in the clause. We can look at this in terms of set notation. Clauses are sets of literals. Those literals are positive or negated atoms. If we take the union of those two sets minus the positive and negated atom, then we're left with the set that is formed by the union of those two sets, minus the positive and the negated atom. So in this case, C and D are sets. They're variables that stand for a set of literals. They can contain duplicates. They can also be empty, right? You could have the very simple case that you find at the end of a process of doing resolution when you have an unsatisfiable formula or theory where P and not P resolve to false, and you're done. The key issue for this video is that P is a single atom. You're only allowed to resolve away an atom and its negation, only one pair at a time. You're not allowed to do more than one, yet it's common for people to misunderstand this and try to do more than one, and so this video is an attempt to explain, well, why that just doesn't work. So let's look at some examples of this. So simple, it's a very simple case other than the sort of the last step in an unsatisfiable resolution. Let's say that we have not Q or V, and we also have not V. Well, the V and the not V are resolved, and we're left with just not Q. Next case, slightly more complicated. Let's say we have not Q or V and not V or not Q. Here we have the same literal appearing in both clauses aside from the positive and negated atom. And so we don't wind up with two Q's, we just wind up with one Q. The V and the not V cancel out, we remove the duplicate, and we're left with not Q as the result of our resolution. Now here's the more interesting case, the case that's really the topic of the day here, that we have two clauses, not Q or V, and Q or not V. So we've got two pairs of opposite atoms with opposite sign. One's negated, the other isn't. We have a choice of which pair to resolve, but crucially we can't do both at once. And in fact, even if we just resolve away one pair, we do what's allowed under resolution, it actually isn't very useful. If we resolve away the V and the not V, we're left with Q or not Q. Well, that's a tautology, right? And in a proof by resolution, we're trying to determine if the system is unsatisfiable. We're trying to derive a contradiction. So if we derive just true, that doesn't help us at all in our process of resolution, right? So it's not useful. Why doesn't it work to resolve away both of those opposite atoms at the same time? Well, let's just look at a truth table and try to prove this. If we were to allow these two clauses to cancel out, not Q or V and Q or not V, well, we'd be saying that they're contradictory, right? That's what happens when we get P and not P at the end of a resolution. They cancel out, and we derive false from that. We derive a contradiction because P and not P are contradictory. Well, if we were to cancel out not Q or V and Q or not V, we'd be saying the same thing, that there are opposites, that they cancel out. Well, just let's look at the truth table. So we can go through columns 1 through 4, looking at all the possibilities of each of the atoms in their negation, then start combining them into formulas. And if we look at our two formulas, then column 5 and column 6, they are not the mirror image of one another. They're not contradictory. And if you want to be super sure about this or super obvious, we also have column 7, which is the negation of column 5. If these two formulas were contradictory, then we'd see that 6 and 7 would be identical, as well as 6 and 5 being the mirror image of one another. Right? 6 and 7 are not equivalent. Right? The second formula is not equivalent to the negation of the first formula. So we know we can't do this. We don't have opposites. We cannot resolve them away. And this is why you must always just resolve one formula away at a time. In fact, if you have, as we've seen in the previous slide, if you have two different pairs of atoms that you might consider resolving away, that isn't actually going to be a useful resolution to do. Okay, I hope this was helpful and allowed you to avoid a common pitfall in use of the resolution rule.